Builders Night Virtual for Dallas Robotics Club, Personal Robotics Club. My name is Carl Ott. I'm the current president of the club, and we're going to do what we normally do each Tuesday night or Wednesday afternoon, depending where you are, where we just go around the table and talk about topics, the things we've been building in the last week, things we're thinking about building, things we have thoughts to discuss. And for tonight, it sounds like Doug D has a topic related to something that came up on our monthly meeting on Saturday. The new club project for the year, a telepresence robot, where we've basically subdivided tasks into several different areas. And I think, Doug, if you wanted to just lead the discussion on the API, let's see where it goes, and then we'll move on to the next item.
Okay, well, I don't have that fancy graphic you had, but last Saturday the club talked about being able to create an API that could be a universal controlling mechanism for robots. And then you would just have to write against the API to do your robot. We talked about making a club bot that would use this API, and I volunteered to do the internet and connectivity part. So let me, I started a document, and let's see if I'm any good at this. And let's see, with any luck, there's my document, and you'll see it. So I've started a document, and basically I'm going to put down what the requirements are, and I've discussed how you might be able to do control over the internet, and then I've done some research on how those things might be implemented. So I haven't gotten very far. My intention later on is to say, okay, function, if I could spell right, has parameters, and then these are how it's, something along those lines to show that how you're using things and stuff. But I haven't gotten that far yet. I've only just begun because we only just started talking about it Saturday, and I'm gonna finish the sharing on this now because there's not a lot to see. Why bother, right?
Well, I wasn't in those conversations, and hopefully I'll go watch the video that comes out on the thing to see. So I may be talking out of turn. But did we decide that? I know you're already generating documents, so so they need to stick somewhere. So I would think that at some point, not some point, like already, we need to have a repo out there somewhere that we can all access, so you can put those documents. So, Doug, you're an awesome person, but we have something called the budget.
When being a fan on a budget gets tough, our agents do the legwork, so saving.
Turn off the radio, Harold.
You're made of, we're made for.
Where's this news coming from?
Have gotten their first doses of a COVID-19.
I heard the radio in the background.
He's watching TV.
Could be a Doug or a Harold.
Condition. You're the phase 1.
Looks like Harold. Harold got his screen open somewhere.
It shouldn't be me, but
look like that's
oh, wait a minute. It is.
We're all silent, and it's your green bars going flippity flippity.
Okay. I have no idea why that was taking so long to do anything, but I haven't touched that. I hate people.
So you were talking about a repo, and I was thinking we're going to use GitHub, but I don't know.
Okay, so I don't know the whole specifics of all of it, but it needs to have a role in there, like secretary at Pres or president at DPRG or something along those lines needs to probably own the repo, own the GitHub account, and then give us a repo on it, access to it. I'm not trying to be complicated, but we have this thing called a bus factor. And Doug, you're awesome, but if you get run over by a bus and you're the only person that has this information, now we've lost.
Exactly. I appreciate the awesome.
So this is a great segue then, in a way, because there's, I think, a couple different levels, or in the way I think about it, there's a couple different levels of collaborative documentation stuff.
Yeah.
And the first is that the club does have a GitHub account, and we do have various repos in here already. So I would think that as the project takes more form and as we have things that are in a more shareable, version manageable kind of a way of thinking about things, that this would be the logical place for us to store it.
Carl.
Yeah.
Well, I've been doing this stuff professionally for, I don't know,
Exactly. So I would lean on professionals.
There's many people, and there's a lot of people who've done this as well, I'm sure, in the club. And all you need to do, it's not complicated. I've got a GitHub account that's just a private account. But if it's a group account, if you think about us as a team of developers, all you need to do is just basically, if you want to commit code we create a new project for this project in GitHub, and you just basically say, I want to be a committer on the project. And then we, as a group, have a team of, let's say, 4 or 5 or however many people have asked to be committers. And if you are able to commit to that particular repo, you are now part of that project team. And if you screw up, it's your problem. But this is not complicated. It's done, I'm sure, 1,000 times. And
it truly is not. It's just a central location where, and as far as committing, Murray said committing code. I'm going to go broaden that just a little bit. Or if you consider, Doug, your document right there, some form of code, you can consider that it just whatever it is that make this project happen goes in that thing. Binary files don't do so well. Text and stuff do better, but still, nonetheless, it's there. It's saved. It's not going anywhere, and then we all have access to it. And as far as the way, and every team that I work on, everybody has commit rights and the delete key. So I don't want to be adversarial, and it tends not to be, because everybody wants to do the best job they can. So if there's something you don't like in there, I believe I want to empower, and I know I hate that buzzword, I want to empower everybody to say, that sucks. I want to make that better and make it better and commit it. And if somebody else goes, oh, that sucks too, well, then maybe they make it even better still, or revert it all the way, and then those two folks are having to get together and then come to a consensus.
Harold, it's even less complicated than that. That if you have a team working on a project, you work by consensus on what needs to be done.
Sure.
But if someone has a disagreement with what's actually going on and they really don't like what's going on in general, Git, as opposed to SVN or any other of these technologies, is designed to allow easy forking. In other words, you can fork a repository off of Git and basically create your own project.
Yeah, I'm just trying to keep a mainline kind of thing, or one tree thing going forward, as opposed to all these splintered things going everywhere. But,
so, Carl, back to
we're good people.
Carl, you want to give out that website / place that you're describing, because
we don't have a repo set up just yet.
You don't? Okay, I thought we did, so that's why I was thinking.
There's an account with multiple repos, but there's no repo or set of repos associated with this project.
We didn't put in it either.
Right, we have, and so far. So what I was trying to get at is that it seems to me that with the documents, with the things, with the stage that we're at now, it's in such a early nebulous kind of a phase. Like, this is the biggest architectural diagram that there is, and we talked about it for 20 minutes, right? So it seems to me that we need more like a shared drive or OneNote or something that we can all put our thoughts in, and then as we bring those together, I think it'll start to make sense to have codes that we can commit into branches.
Right,
Yeah,
but
I
the
think
key is, do we have a spot out there on the GitHub for something like that?
So we have a spot on the GitHub. We don't yet have a DPRG like shared drive or that I'm aware of, or
if you do it with the GitHub, if you go to the GitHub account you got there and say create new repository and select a thing, then it's done. You got a repo. And then there's permissions and stuff that you can worry about afterwards, right? But then at least one person we can submit PRs to it almost immediately to get Doug's stuff up there and everybody else's stuff. It's done.
Carl, all you'd need to do is create something called Telerobotics API, and then when you create that new repository for the project, it'll generate that repository and it'll put a README file in there, and that's the beginning of the project.
And you're set up. At that,
And
and
I get that. I've done it a number of times. What I'm thinking is that we have a wide mix of skills with Git around the club, and I think it's I just wonder if it might be too early to get into this level of version controlling, because I could easily see that if the it's with the blobs, with the way it manages non-text things like PowerPoints and sketches, you can't really manage. You can manage a new version of the file, but you have no idea of what changed inside the file.
some of that's a
Then
bit.
why do we need to use binary files?
So I have a suggestion. For a temporary startup management, I can email stuff to Carl, and when he gets something set up, then he can slot them in. He'll have something to start with. He can be our source management for now.
I don't know if Carl wants to sign up for all that management, but I'll let Carl speak for himself.
I don't know if I want to be in the middle of that. If anything, I would say what we could do is something like that. I'm sorry, I had meant to ask Steve ahead of time. Maybe Harold has some ideas on how we could use some of the Microsoft tools. But
yeah, it sounds like you're looking for something like OneDrive.
Yeah, that's what I was thinking. Or because I only have my personal OneDrive, and I guess I have a personal. I was looking to pull that up here. I got a Makerspace account, so we could just take a folder on the Makerspace. Well, let me just ask it this way: how many people, if they had a choice and you had to pick one or the other, how many people would lean towards a login to Google, a Google login versus a Microsoft? So how many people would lean towards a Google login? Raise your hand.
Actually, there's three options. One of them is, can we have a GitHub option as well?
Just do the Git, just a place to dump. Anybody can dump whatever.
Basic GitHub.
Committer on the project.
Well, I think what you would start with, Carl, is you'd have in your repository, you'd have subdirectories, and one of them would be documentation. So in this case, what would happen is Doug D's file would go into the documentation. All right, and I know what you're saying. You don't want to really see people putting PPTs or.
I do want to see PPTs in there. I'm just concerned that it's not meant for. It's a difficult thing to collaborate in that way.
Yeah, for regular just random files, I don't think you want to be burdened with that workflow that's associated with GitHub, right? I think that's what you're thinking.
That's
well, if you can
on that, by the way, me and Murray are like, I got a finger macro and I do all this in about 27 seconds at the most, and I'm done.
Yeah, I don't understand why we're even using binary files. If we just need documentation and planning, you can do everything in text files.
Yeah. If you do Markdown, you get a nice looking file out when you do. And
I mean, how would you do this in a text file?
Yeah.
Why do you need to do that?
What?
Why do you need to do that?
This sketch?
Yeah. If
it's worth 1,000 words,
isn't it? It doesn't change that much, does it?
Well, so we don't know. Hopefully not. I mean, I try to draw it in a way it would be relatively stable, but
well, you could
open that file. Useless to me.
People might want to use diagrams too.
Yeah.
Well, I can't even open that file.
You can't open PowerPoint?
No, I don't have PowerPoint.
You can open a PDF though.
Yeah. But we don't. Yeah. But that's even more binary. All I'm saying is, you guys are like finding a technological solution for something you don't even have as a problem yet, which is documentation.
Yeah.
The only thing I can think that might be more universal would maybe be SVG, but that would require people knowing Inkscape or SVG editors. But I think the total cart before the horse problem, because what we're trying to do is plan something. And if this is a one-off, then yeah, make it a PowerPoint, someone owns it. But the real problem here is code, documentation, a standard software project. And when I say software, I agree with Harold. It's all the documentation as well.
Every project I do, the very first thing I do is I go to GitHub and say, give me a new repo, and I pick up some weird-ass name for it, and I give it to it, and I go. And that's where I start every project that I do.
Right. Yeah. So why don't we just do that then? We'll call this DPRG DPRG telepresence bot, or how about telebot? Because I don't want to type presence all the time.
Now you got a real problem because naming things is hard. And
It's better than
Telebot
telebot.
Telerobot API.
In the 80s, all we had was ASCII art.
oh, there you
Yeah,
go.
well, you have Markdown. You can do wonderful things with Markdown if you want to take the time. I mean,
Yeah, there's
I mean,
And I've seen, there's people that have documented entire websites using GitHub, so I'm totally not against that at all. I think it's awesome. So, but, okay, that's cool. But so
no, that's another option. You can even do HTML if you're into
Right.
that. You know,
right. I was gonna show you. So like,
that's just a version of Markdown.
And,
Like-
and, in fact, and there's even a more crazier thing too. If you go to culture.biz, my website is sucky as it is. That's on GitHub. That's you know, it does all the stuff it needs. Well, not all the stuff, but lots of stuff, and it's on GitHub, so you know where it is, right?
you said culture.
Culture.biz. No, culture. P.
Like in Harold Culture.
Culture.
Pulcher. It's close, man. It's close.
I'll get there. Sorry, Harold.
That right there is a repo on GitHub that I've assigned a name to it that knows how to do a CNAME and goes there and it's got a little bloggy thing. Well, the way I've got it set up, it does a bloggy thing. I store all my assets there. And the whole deal is I get up, I get a markdown page the way I want it. I commit the repo, and now my page has been deployed and updated.
All right. Seems
Okay.
to me that. Okay, good. So let's do this.
So let's go back.
I set myself up for making that happen for the club, but I didn't really mean to do that.
Okay, so we have a name for a spot now, right? And then within that spot, I would say maybe you might have another spot for people to deposit files or whatnot that we can process and look at, and then go from there.
Yep, I would say add a README. You might want to throw a get ignore, maybe not on it. You probably want to choose a license on that, and I am not a licensed person. So I usually choose the Apache thing, but I am not up on my licenses, so do not listen to me. Hopefully somebody else has got a better idea than me.
Don't use the GNU license though. That has lots of ramifications. You can use the MIT license, the Apache license are both good for this kind of thing.
Okay. Get ignore. Okay, we'll worry about the get ignore later. Okay.
And so, and I will sign myself up as well on anybody that comes here and has a problem with Git or needs to say, how do you do this or what do you do with this? I'll be happy to help anybody. I'm on Messenger, Facebook. I am Twittered. I am all that stuff. Carl and I talk not way too often, but sometimes way too times a day. So I'm available to help.
Well, this is screwed up. Why is this no green button? It's not showing the love.
Hold on.
Oh, you can actually use hyphens. So if you want to put telebot, you can put API hyphen API. I mean, yeah, like that. Yeah.
You probably need to make that public, though. I think there's restrictions on how much you can do for private, but I don't remember.
It's not taking the button in any.
What's it worried about? What's it not doing?
Refuse to frame.
Pick another name. I mean, does the name have to be globally unique in GitHub? I don't think so, right?
No,
Within
only within your own
DPRG.
repository.
Yes, it's definitely.
No.
All right. I've done this so many times, and of course, it's only on the recording with 35,000 people that it's going to do this.
Content. It looks like it's actually your browser that's having trouble.
Yeah.
It does seem that way.
So once again, it's not something we're going to use this very minute, so I wouldn't pressure you to do it this very minute. Just once you get done, you can let us know.
Hit your green button.
I hit the green. Okay.
Yeah,
So why don't we just move on with this discussion though? But I think this alone is a good progress. It's a little different direction than I was thinking, but it's fine. I think it's a great direction to go.
Well, we can always revamp, but this will at least give a starting point.
Yeah. No, what I meant was that I would not have guessed it starting off this way, but that's cool. That's why we have such a
And
why
Carl,
diversity?
in terms of the PowerPoints and the binary files, those aren't really the ones that matter. You don't really need change control in those anyway, because someone's going to own those. Like you're going to own that particular PowerPoint, and if you update it, big deal. We don't need change control on that. It's
Yeah. No, we're on the same page, Marie. No
Yeah.
doubt at all. It's just how do we, like to Doug's point of, he's got this draft and he wants to circulate it. So, a convenient way to circulate it, modern way, is on a collaborative file system, or we could use the old way, which is like email.
How about no on that? How about I got a big old bag of no just for that email.
I was going to say no for email. I got too many as it is myself.
Full disclosure, I'm not going to be uploading that to the spot just yet. Donna and I are going to be collaborating because we're the two on that list for that section. And
Cool.
when we're just a little bit further along, we'll upload it.
But when it's ready, I expect you to get a thumb drive and hire a courier and have him run it to me.
Oh,
And then let's have the secret handshake exchange.
when he gets there, he's going to want cookies.
Okay, well, in that case, he'll have to bring a 1 1/4 inch floppy.
Yeah.
Okay.
You guys
You're
are
going to send it through the mail. That might be fast, right?
For the night.
I think it should be a 5-inch floppy.
Oh, you said a stack of Hollerith cards? Is that the deal?
You ancient dinosaurs.
You better. Run it off on an 027.
I think they should arrange a Babbage abacus kind of machine and then just carry it without tickling it too much.
Or a 5.5-inch floppy or 8 drive. Yes, 8 track.
Many of us have been there. Yeah.
So in addition to having started my document, I also looked at some of those telepresence robots that John put up last time, and I'm going to pick one of them and actually get started, and I'm actually going to order parts soon. So
Okay.
we'll see when I get it put together whether it really does as advertised.
Oh, wait a minute. Yeah, no, we need to get my DASD out and run it over to you in the back with a forklift for you to go.
What?
Hey, so
I would say go for the small plastic one. That one looked cheap, and you'll probably have all of the parts already around your house. The one with the real plastic.
I was torn between doing exactly what it said or modifying it using parts I've got, because I thought our goal was that we wanted a universal robot that could be like, here's the design, everybody else can build it. And people won't have the same parts laying around. That's one of the reasons.
Well, my
No,
point would be is
I don't think that's the goal of that. I think that goal was directly for creating telepresence.
right.
Yeah,
Right.
the other
That's
goal,
about all
the
those
other
are
goal,
for
the other
that.
goal is different. So
But my point would be on the one is that it's reasonably low price, and those little motors. In fact, probably let me reach up.
While he's reaching out, I'm going to peel the screen.
I have a question. I obviously wasn't there on Saturday. One of the things that occurs to me, and you can please shoot me down if this is a crazy idea, is that you guys seem to be creating an API that's kind of like the all-purpose API, and it sounds to me that you want to have maybe a very high-level API, or at least an abstract set of concepts, and a low-level API, which is actually code-based.
yes,
I thought
Yes.
I kept this. Sorry.
Murray, you're spot on. From a glance at that diagram, I think you've nailed it. But I think there's enough people that weren't on the call Saturday.
Right.
If it helped
See,
the discussion, it would.
This is one of the cheapos.
but that's why I would say something like this is similar to that.
Model. We gotta have somebody go get a model for the thing, get the black turtleneck up and bring your hair long.
I'll do it.
Would be that.
This is the one John was recommending as the cheapest and easiest.
Something along that. Well, I think it's reasonably priced, and then from there we can have an upscale. But all projects, really, the best project is the one you have a base to work from. I've seen so many projects where they jump too high, and you tend to fall more.
Was that a container store robot? Is that what that was?
It sure
It has a
was.
plastic
This
top.
is the one I was leaning toward, but I might go ahead and do that other one first. The other one requires an Android phone.
Right. And everybody had Android phones to a high degree.
I actually
Even
have
though-
them around.
I think
So let me,
you can probably get an Android-based phone pretty easy these days. Not too
Yeah.
expensive.
Did I leave the meeting?
no, you
No.
just stopped presenting.
Okay.
You're still here, Doug. So let's catch everyone else up because there's, I think, a healthy contingent that weren't on the call Saturday. So the basic premise was that we had a couple of things we were observing, like there were uh, uh, we have a nice participation of people in Dallas and people who are beyond Dallas or coming virtual from Dallas, and we were looking for things that might make sense to collaborate together on in the club. So these two ideas kind of surfaced with some kind of DPRG platform. We've done those in the past, but the idea was maybe we focused on this year one as a telepresence robot, and maybe do a kind of a club robot build using modules that different teams around the world contribute. And at the end of the day, we thought, okay, well, telepresence robot. So if the problem is you got people somewhere and you want to have this kind of semi-autonomous robot in a place that can represent that person, kind of let them zoom in. So then we need the stuff in the middle. And I just threw this down as a kind of a way to think about breaking it down. So a top level kind of decomposition. And that led to some discussion and grouping in a way that we have a couple of people who voiced an interest. So the idea was that if we think about this as a like a participant outside of Dallas would need some kind of control UI, and then the robot would have to have some kind of interface. Well, the easiest way to do media streaming would be Zoom or Meet or something like that. So you use these standard tools, just strap a phone on the robot, bam, there's your camera and your audio and your screen. So then we can focus on the things that are probably easier for us as a club, given the membership, which is not media streaming, but more just robots, driving robots around, sending commands to robots and understanding sensors. So that's where this left thing would be where the focus, the real big focus of the project was. And the idea was then that we'd have this part, they'd have the control client that the remote person or the person away from Dallas would drive by and view by. And then that client would hit an API to some DPRG server. And then that server would use an API that reaches down into the robot. So then the participant remotely could say, move forward a foot or drive over there or turn around or whatever. And, most of the club teleop robots so far, they're all like point-to-point local interactions, right? Where you have low latency. It's fast enough response that you can drive on a joystick in your hand and the radio to the robot and it moves quickly. But now when you have internet protocols and thousands of miles in between, it starts to tend towards like the Mars rover, right? 20 minutes of delay, the robot has to be pretty damn smart to do things on its own. So this we decomposed then in a way that, well, if we think about this as like APIs and a server in the middle, then we could, and if we abstract it in a nice way, then you could imagine the API so that, anybody could write a different client, hits the same server instance in the middle. Anybody could have a different kind of robot, it hits the same command structure. So we have one guy who's gonna, Doug E. We haven't seen him too much on the Tuesday night calls, but he and Jean are gonna go look at a handful of different robots that already have APIs. And those will be some kind of benchmarks for what kinds of commands would you send across the API, right? And then Doug D and Donna, we're going to go look at on the robot side of things, what kinds of API pieces would they like there? And then Steve, who's not on the call tonight, but Steve and I are going to look at our own thoughts of what API might want to include on either side, and then how to go implement it on the server. So to me, the cool thing about this is that if we are clever in how we abstract this and how we break it down, we can have a server then that you can plug in any kind of robot you want. As long as it respects the API, somebody remotely can drive your robot around if you want them to. So that's kind of what we were talking about the other day. Any thoughts or questions at that point?
So is this going to do like Cain and kung fu and wander the earth, or what?
Why not?
And we know it's doable because this little toy here was something I could drive through the internet before its battery ran out. It was called AppBot Riley, and it didn't have a screen, but it had a camera, and I could, on my phone, drive it and make my dog go crazy when I wasn't in the house because my dog hated it. But it's certainly doable. We just have to work out all the pieces, and I was pretty excited about Carl coming up with this idea.
Well, wasn't just me, but
Well, Carl, yeah, I've often, since, I mean, I worked at NASA for about a year and a half and had direct, I mean, I wasn't on the robotics team or anything like that. I was just an IT person. But I've had a huge fascination with telerobotics and what that meant. And so I'd be quite keen, probably not to get involved with this project at the code level, because I'm not going to be implementing it down low. But I think, as you may know, I've got one of these things, and I've been controlling my robot with one of these. So what I would probably try to do, just as a matter of input into the group, is I would probably try to look at what high-level API you guys design and probably reprogram how I communicate between this and my robot. And that would be in Python. So in theory, if I could get that working according to the high-level API, like the abstract API, I could contribute that code, and then anybody with one of these things could theoretically communicate to a Raspberry Pi, and then you'd have a Python file that you could then implement your own client code.
It's beautiful. The Pi is getting stuff from the internet instead of you pushing on the buttons. Exactly.
Well, yeah, I'm not interested in having anybody else control my robot, but that high-level API would do exactly the same thing. I want this robot to go north 3 meters, turn left, avoid, whatever that happens to be. But that kind of goal-oriented task, that's the way telerobotics work, is, you say to the Mars rover, we've got a particular waypoint, and I want you to go and explore in this particular direction for the next 3 hours, and then you've got 7 minutes of delay, and the thing's got to survive for 7 minutes until it can come back and say, I've made it to the waypoint. But that kind of telerobotics is quite fascinating, and I think it's really educational for kids to see how that works as well, with that level of autonomy. So, yeah, I think it's a great idea. I'm not sure how. There's lots of different places for people to fit into this idea.
And that's another thing that seemed to be cool, because there's a recurring interest now and then that people want to try and do some things together and stretch a little beyond their own skill set that they have, but not too far beyond. Mm-hmm. And I think this is a cool way that we could do things together. So, and then have something to show for it at the end, right? That could be built upon.
And part of the way that all came up was we were talking about keeping Murray and Crisp and Pat and all these people that aren't in DFW areas still involved with us when we get back to in-person meetings.
Yep. Well, it sounds like a good idea. Like I said, I think that you'll find that people will have different levels of involvement at different places in this project, so it's got lots of options.
Which is cool.
Yep.
Yeah.
Yep.
And,
okay, so we've agreed. We'll definitely use GitHub for code and those kinds of text-based management things. But for now, as we pull things together, well, whether it's email or a shared folder, we still have to figure that out.
So once you get your GitHub going, be sure and put your PowerPoint out there so I can look at that picture as I'm laying in bed waiting to go to sleep.
Yeah.
Yes.
Well, so Doug, I put did you get I sent you a PDF of the presentation from Saturday. Did you manage to get that on the website? Or?
Yeah, well, it's on the web. It's on the web.
It is. Oh, okay.
Yeah. So, okay.
Probably email.
So, Doug, all you have to do is go to the DPRG.org website, go to the annual meeting. There's the video link, there's the chat record, and there's it's called Carl's.
That sounds
Carl's
good.
deck or something. I can't remember. Slide deck, I believe.
Let's go there right now. So it's under here?
No, go to news. Well,
it's under news.
Yeah, just click that.
Meeting
all right,
now
slide down to the annual meeting. No, Get on the orange dot, on the orange rectangle. Now slide down. There you go. There it is. Now slide down a little more. So there's the meeting, there's the chat record, and there's Carl's slide deck.
So
Doug is on top of all this, man. That's a lot of work there, Doug.
Doug is awesome. I mean, it's a lot of work to do what he does. So
it is.
Yeah. One of the benefits of being retired.
Guys, sorry I had to miss a few minutes. Did you already cover sort of how to, on the collaboration side of things, we covered the file part, but how to cover sort of communication, right? Something like a Slack or equivalent. Have you selected something?
Oh, I like that concept. No, we haven't. That didn't even come up until you brought it up now.
Because, I mean, it's either going to be email, which, is gets a little out of hand, or it's going to have to be something like a Slack.
Or else do Tuesday even talk like now.
A lot of gamers and that kind of stuff will use Discord for a lot of things. Slack is the thing. I would tell you, as much as I'm a Microsoft person, I think Teams is, for this situation, is probably not what we want to use. Even though
Teams is too much.
And probably not free either.
It's too heavy. What now?
Probably not free.
It is free to a certain size, which I think we're underneath that. But there's a whole organization thing that you got to be in the right domain. It's an AD deal. I have all kinds of problems with it, and I don't think I'd be using it if my organizations didn't already use it.
I would suggest right now, let's hold off on that thought until next week and use Tuesday's meeting sort of as a clearinghouse right now.
Sure.
Has anybody used Confluence from Atlassian? And I don't know if they have a free version of it, but I'm a big fan of that. We use that at work because you can do you can talk, you can put content there. It's probably a little heavy on the content side of things, little lighter on the messaging side of things compared to Slack, but I mean, it's a great tool in my opinion.
I don't think it's free though.
Probably not.
It's not free. I've used it on several of my clients because the client was paying for it. The client decided that's what they wanted to use, and they got a wiki aspect to it. Of course, they've got storyboards and all that kind of stuff based to it. It's a big thing, but it's definitely not free, and it's pretty weighty for I think what we're going to get in the middle of. I think
maybe Slack is the thing then.
I would go for Slack.
I say Slack or Discord, one of the two.
Slack or Discord.
There is a simple way. We can create a mailing list specifically for the people who are in that list.
I like that idea. And
then you just email the whole list. That's not hard to do. Carl, if you get a list of names, I can create a mailing list. If it gets bigger than that, and if you need more, well, then we can go look at it. But here at this level, I think a mailing list would be the best way to do. Now, the one thing I got to tell you guys, because Carl's really bad at this, I put him on a mailing list, and he keeps emailing to it, even though we're not. He is technically not on the list anymore, so I have to go in and clean that all up. So, like Carl, take off anything that says DPRG Roborama committee or whatever. Don't email stuff to that. All right, but I'll call it the Telepresence API project, and or something like that. And if you give me a list of names, I'll make the list, and you guys can email back and forth all you want. And it's pretty.
That sounds like for initially that would be the ideal.
And then
we can evolve.
It'll be archived. Wherever. It'll be archived, so you can always go back and look at it. And if you need to take it to some other platform, it can be zipped and transported.
So you think Slack would be just too much work to set up, or people are not familiar with it?
I've used Slack. I wasn't crazy about it. I mean, I didn't see the real advantage of it, to be quite honest. If you're talking about somebody who's making 50 messages a day between them, blip, 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 it could be useful. But if you only got somebody who's maybe making a message every 2 days, it's a little too much. And it is, it's another application you got to, or window you got to have open. I just prefer email, and it's easy for you to, in your email accounts, to go ahead and screen on it if you just want to look for those particular emails. So I'm just saying that if it gets bigger than that, then we can handle it at that time. But at the beginning here, all I need is a list of people who want to be on the list. I'll put their emails on a new DPRG list, and you'll be there. So that's how
Doug,
I would do it. Yeah.
Doug, one of the things that I found, one of my mentors was really big on history, and I don't mean like human history. I mean like project history.
Mhm.
And he kind of impressed upon me thinking long term, like really long term. Like he's like into 100-year long term, but for something like this, think 10 years.
Yeah.
And so if we do something like
I
this,
hope I'm
it'll
still here in
evolve over
10 years.
Well, the point is, though, is the project might, and it'll evolve over time, and it will change. It might die, but if it's around in 5 years, it could easily be around in 10.
Well, this is automatically archived, so I mean it's there. You can go
Well, my
back.
point is, if we use Confluence or Slack or anything like that, that will have to be maintained. Whereas an email list on the DPRG site or a wiki or anything that's actually owned by the club, like even like the GitHub site, all that stuff tends to be very long term and can be maintained. As soon as you get into conversations on a site that might not be maintained for 5 years, certainly not 10, then you're going to lose that history and all the conversations and everything.
I've never used it, but well, I kind of sort of use it. But for me, wikis are where things go to never get read again. That's generally what, for me, I find out. But there's a wiki on GitHub as well. So, I mean, it has tools for doing almost all of this stuff we were just talking about already in the GitHub thing that we've already set up, that what Murray was just saying, and I agree with, that it's already something where we're going there anyway most of the time, or could be going there. The club is going there, and it's just not going to get, out on a leaf node somewhere and die a horrible death. Much like my web, much like a web page is right there, right? So.
Well, actually, the guy that I was talking about, this mentor, the reason that wikis even exist is because a guy named Ward Cunningham was trying to solve actually this kind of problem. I mean, it was basically how to keep history on projects. And so the wiki, whether it's good or not at that, may be arguable, is actually something that was designed to keep track of people's conversations, plans, all that kind of stuff. And the idea of a project that's meant to live like this one, which is meant to, it sounds like to me, it's meant to live a long time, 5 years, maybe 10 years.
Yeah.
Right? Then it's something that you want to put on a non-proprietary platform, I'm sure.
Yeah, I agree with
At least one that doesn't change every other year. I get tired of. I'm getting to the stage where I'm
Okay,
getting tired
so
of
here's the
learning
action.
many new things.
We got an action, guys. The action is, if you want to be on this project's list, email Carl and me. Well, you can do that by doing president@dprg.org and secretary@dprg.org. And I will, and yeah, you can do both, and the list will be created, and you guys can start. I'll send you a test message so that you all know it's live. Okay, it'll happen tomorrow. All right. So that one's solved. Okay.
Cool.
That's cool. I have something. I detected a pause. I will take off the magic 8 head.
Ralph helps so much.
Yeah, that's my cat helping. Chris, I promised Carl that I told him not to say anything, but I said I would tell this to you directly, and hopefully, you take it in the manner it's perceived. You were absolutely 100% correct.
About what?
About the ROS communication between machines. And as soon as I put in the domain ID, which the documentation says I didn't need to if I just wanted to use the defaults of stuff, things just magically started working and doing what they were supposed to do. So I want to get some, as we like to be nerdy and call out lots of details here. I'm a high S, by the way, which details seem to, I don't care about the details, we'll just make it work, right? But in this case, I want to call out some details that I've learned because I was happy that I learned them. It seems that this ROS 2 is using something by eProsima. It's a communication. It's how it's doing its bus. It uses multicast UDP over your local network to do what it does. And it starts at port number 7400. And then applies a couple of transform to that to get your real port numbers that you're using on. So in case you want to know, your IDs can only go a maximum of 232. I found that out the hard way. There's a nice little error that gets thrown because that multiplication starts at 7400 with some multiplication addition, gets you to the 64K port maximum number, bust that out at 232. I found the source code where it looks in there. I didn't find where it wasn't working because I didn't give it one, but I did find that calculation. And the fact that it's using the multicast UDP is exactly what you would expect it to do. It throws it all out. Whoever's listening to it, because that's the way ROS is designed, whoever's listening to these channels and doing this thing will pick it up and do something with it. And if no one's listening to it, and there's no way for the sender to know whether it got delivered or not, it's just spewing noise. And saying all of that, Chris, I'm going to ask you something else. I want my teensy now to talk through my USB to my on a ROS node so I can talk to it from my lab machine. And I found a few things. One of them was a ROS to Arduino, and the other one was micro ROS. And there's a couple of other ones that are slightly older. I've tried the first two straight up, and I've got some work to do, and I want to know if you've done this already, and because I don't want to expend, not that I don't want to spend the effort, but if you've already made some inroads, I would like to spend my effort wisely, that sort of thing.
So the answer is in ROS 2, I haven't, because I just still in the process of switching over to ROS 2 and getting everything up and running again on my Romy platform. In ROS 1, I had used ROS serial.
Yeah, I saw that for ROS 1. Yeah, I did see that.
Now, but what? I've used it, but then in the end, what I did even in ROS 1, and the same concept applies in ROS 2 as well, is specifically on the Romy platform. Where you have a microcontroller, an Arduino, type, an Atmel on the Romy control board, and you have, you've got the Pi on top of it talking I2C. I'm just using the Pololu libraries out of the box, but the concept applies regardless. How the Pi or whatever you've got, right, talks to that other microcontroller doesn't really matter. It doesn't have to be a ROS compliant kind of mechanism, right? Yeah. That's why I've said previously, I don't think you really need to run this micro ROS on your microcontroller, even if it's technically capable of doing it. You don't have to use ROS serial or whatever else is the equivalent in ROS 2. At the end of the day, out of your microcontroller, in my case, it gives me the odometry. It controls the motor without any feedback loop right now on the microcontroller. I give it the speed, it produces PWM. It has some analog inputs, right, and the buzzer and some LEDs that you can control. And so all of that is going over I2C between the Pi and this other microcontroller platform. And then on the Pi, I have a Python script that uses the Pololu provided Python library to pull out, let's say, the encoder data, 50 times a second, 100 times a second, and then I just publish that, like you would with a normal ROS node. My point really is how this Python script talks to the microcontroller doesn't have anything to do with ROS, right? It's just done the way it makes most sense for that particular setup. And I've seen it, I've done it a similar way, again, not from scratch. I've used what was provided on the Kabuki platform in ROS 1. You have a microcontroller on the Kabuki, right? This sort of Roomba-looking thing. And then, it has a serial port. You talk to it over a serial port. That communication has nothing to do with ROS. It's just whatever, commands going back and forth, data going back and forth. What matters is, okay, on your Pi or equivalent, you kind of use whatever API they give you, and then you publish it, as ROS topics, etc. So that's really the main point.
So let me put this in different terms. Kick all this other garbage to the curb, and just write you a ROS node that takes the information, and let that ROS node talk directly to the microcontroller. And on the microcontroller, maybe you write whatever you need to get that conversation to happen.
Exactly, and maybe you're lucky and you've given some libraries, or maybe you got to do it from scratch. But or maybe you use some existing libraries.
Yeah. You're gonna load up the Arduinos with the PWM controllers and all the other noise that you need to do, right? And then you're gonna have that node running up into the host OS that does all the ROS talky and pushy.
Exactly.
And then let it figure out what commands just to send down to basically a firmware that you've got on your, in this case, a Teensy. But still a firmware.
The only difference really, if you compare that to a ROS serial type setup, or whatever the equivalent would be in ROS 2, the kind of quote unquote advantage of ROS serial is that the node that runs on the Pi can actually be a very generic node, right? It doesn't need to know what data comes out of the Arduino, right? Because the Arduino, it's set up to be a little bit more generic in how it communicates. Okay, it's maybe a slight advantage, but not really a big deal, right? In the way I just described it, the node that you create on the Pi now has to know exactly, right, what data is coming out of the microcontroller. It has to implement that protocol. It's pulling out that data, and then it's publishing it. It's no longer a generic middleman kind of node. It's a very specific node, very specific to your hardware.
Yeah, and I think I'm kind of good with that, because I was seeing these things, and although these people have done a lot of work and done a bunch of generic things, and to make this all a bunch of cool, it seems just fraught with problems. It seems like it's very fragile. You mess with just one little bitty thing, and now it's broken everywhere. Where if I write my own stuff and do my own little bit of firmware for the robot that's working on, that's what it's going to work on. The next time I go do another robot, I'm going to need maybe the same things, but then that's a base to start with, right? I don't have to reinvent the whole wheel. I've just got to change it to make it specific for the. It's not like, but that ROS object, that ROS node that I stick out there can be very generic to a point where it takes twists and it takes other information about movement or whatever we need to take it, and we can use all the standard stuff there.
Exactly.
Yeah.
So that's what I'm doing on the Romy. I have a ROS node that, gets the odometry. Not odometry. Odometry in the sense it gets the encoder ticks from the microcontroller, and then it accepts motor commands, from other ROS nodes, and it uses I2C, which Pololu has set up all that mechanism. Works fairly well. Again, I'm just twiddling with it right now, actually, because I do occasionally get some errors, but it's no big deal. Again, it's all kind of just transient. Every once in a while, communication seems to fail, but it's like 1 out of 200 times or 1 out of 500 times. And so, it does its thing there with the Pololu library, and the rest is standard ROS code.
I got you. Cool. I think that's pretty cool. Yeah, I'm going to go down that way, because then that's something. Not that I quite understand it, but I have at least a little bit of handle on how some of that stuff works, and trying to jump into some of this very generic stuff that people have worked on months or years or God knows what it is, and they have their very own opinions about this, and me trying to find those opinions. That's I found that fairly daunting.
So on the teensy, you have your actual PWM going out to the H bridges and.
I'm going to have that. Yes, that's my plan. I replaced that Teensy. Well, the Teensy is taking over for the Arduino that's built into the Latte Panda because that Uno was giving me problems, to say the least. And so I changed it to the Teensy as a test, and I immediately got about 1,000,000,000% less problems. So we're going to make that thing. And since I've got a 600 megahertz processor on that Teensy and a lot of RAM, I'm thinking I can use that to do a lot of things on my robot, and let my smart thing that can communicate to the internet and do cognitive services and all the other kind of stuff do what it's good at. That's what I'm thinking right now.
And you're thinking serial or I2C, but you mentioned serial before. I think
I've got a USB connection to it right now, and I'm going to stick with that until I've got a reason not to.
But USB as in like truly USB, or is that just a USB UART in the loop here somewhere?
I've got there's probably a UART on the Teensy, but it's a USB. I've got it connected right now the same way I program it, the same way I do all the other kind of stuff in there. It's connected up to the Latte Panda directly. I mean, I can show you on the thing, but it's not bare wires. It's not nothing. I'm using all the connectors that came with the board and that kind of thing, popping at it.
Okay. Okay, so there is, all right. So you're going, all right, now it sounds, I mean, I'm not that familiar with the Teensy, but I'm guessing it probably can do native USB. It probably doesn't have a USB UART chip on it. So you're probably doing, you know, the Teensy library probably implementing, you know, USB UART type functionality.
Yeah, probably is. So if you want to see, there's the Teensy, there's a USB connection plugged into the Latte Panda. I mean, that's exactly what's going on there. And as Murray will tell you, I've got about a bazillion ports and PWM and tons of memory and all the other kind of junk that's going on the thing. So I don't know how much of that's how far that's going to go, but we're going to see. We're going to find out.
All right. So, you know, hopefully you don't end up, you know, inventing some protocol, but, you know, oftentimes it, of course, happens. That's what we do. But
that's not my purpose. I'm probably going to use the same basic structure that I get off the ROS, and that's what I'm thinking right now. I'll probably use the same kind of structure I get off the ROS, and then figure out, you know, just send some text down and have it parse it and throw it in, as long as that's fast enough. It may not be fast enough after a while, but we'll see. We'll see on that, if that makes sense. And I've got Murray up and no Murray in his window.
Yeah, he took a.
Oh, there you go.
He took a break. Yeah.
That's much better than a blank Murray window. No, but thank you very much, Chris. That's kind of I'm going to go with that, and I've got some C++ to learn and some other stuff, because it's not that I don't want to learn Python. It's just that you know, I'm just going to hang out in the C++ I think for a while until I've got a reason not to. You know, and that reason may come sooner rather than later, but we'll see. I'm trying to as we on my team, what we do is we do something called write a contract, make it work kind of thing, where we decide, hey, we want this to work this way, so we code it like everything is built behind it, and this is how we want to use it, and then we start making the in Visual Studio you get red squigglies when things aren't defined, and then we start making the red squigglies go away in some sensible manner until we can't do that any longer. Like, ugh, okay, we can't do that, so let's rethink what we learned here and go at it a different way, and that kind of stuff. I'm not saying don't plan this out and don't think about it going forward, but more think about how you use the thing, how you want to use it, how you feel like it should work, and then see if you can make that happen. And sometimes, most of the time, we've been able to do that. Sometimes we get all the way down the trend like, damn it, all right, we were just absolutely wrong there. Now that we know this, we'll make a better stab at what we can do. You know, that's what. And there's learning involved, so that's okay.
Yeah.
Okay, I got a few things I wanted to go ahead and say.
Go.
Okay, most of you probably know I went ahead this weekend and put out uh, a tutorial, a motor driver tutorial about how to use the different modes. If you haven't seen it, it's up on the web. It's directed at the L298, which is really common, and it's also directed at Arduino because that's really common too. But the principles and everything could be done on anything. But it does, I think it clearly tells you the differences between the different ways you can hook up the motor driver, like lock antiphase and all of that. It's all in there. So if you haven't seen it, I would suggest you go take a look. I'd love to hear your comments on it, because make sure I haven't, when you publish something like that, you never know if you've got typos or did something weird. So, I would like that. The second thing is I'd like to talk to David, since I got you here. David, you know this board, right? This is the one for the Nucleo motherboard. You gave me one.
411.
Yeah. Oh. I'm not muted. Oh, the question
Is it David? Is it David me?
Yeah, David A. This
Yes.
board.
Yes.
Okay. If we had to get say 5 or 6 of those, is that something that you would be willing to sell to the club, or could you give us the files and go get some more?
Well, let me see how many I have.
Okay.
What is your goal, Douglas?
Well, the other task that came out of the meeting was the idea of how do we do remote competitions without having to go through all of the hoops and bounds that Donna is doing, where people are sending her the robot and she's having to send them back. So the thought was we have a standard robot base that existed in the club, and people said, well, that's great, but we would like a copy of it too, because it's sort of like, people making their own line following courses so that they can practice at home with their robot. So what they wanted, there was people that would like to build a copy of whatever the club robot was that was the standard for them to use in the competition. All right. So, and I took on the task of saying that, okay, I'll review the 2016 club robot, since I already have a base. I have an extra base for that, and it's like anybody, I don't want to do the same thing over again. So what I want to do is I want to update it to a Nucleo board. I want it'll be, I'm thinking of having it, redoing the front so that people can have at least a claw and bumpers and a few things. Probably going to add some sharp sensors to the side, but it'll be, or I don't know, it might be the STI. You know what I'm talking about, the VL05, whatever, but it'll be something like that. So there'll be some upgrades to it, but I want to make it so that we have a standard base, so that somebody just has to send us the code, and then they can compete in the contest. Now, and like I said, people said, well, hey, yeah, that's great, but I want my own robot so that I can test it at home before I send you the code, which makes sense, okay? So that means I'm probably going to do a group buy for this new version of the 2016 robot, and we agreed that the price would be, you know, providing there's no issues, the price would be $175. Okay, I'm hoping to come in lower than that, but you know, I'm not going to make any compromises on quality to be able to do that. So it'll be a good robot, and I think Joe wanted one. Am I getting that name right? No, Pat. I'm sorry. I think Pat wanted one, and John wanted one, and yeah, and there was and Doug wanted one. So there was a couple people at the meeting that said they would want to do it. So I'm thinking, Dave, that it'd probably be around 5 or 6, maybe. You got, how many you got? Huh?
Are you talking to me?
Yeah.
I'm sorry, I got carried away.
Yeah.
We were doing an interpretive death.
Okay. How many?
I've only got 5 of these left.
Okay.
Ray,
so
you have one, don't you?
Well, we might do
And I sent one to somebody else. I think maybe Steve has one. However, you know, Ron made these boards for me.
Right.
And they were cheap and quick and easy to get. And I'm sure he could get as many made as we want.
Right. The only thing I want to...
Matter of fact, there is a mistake on these boards that requires you to go in with an X-Acto knife and cut a trace. And so if we're going to have some more made up, that mistake needs to be, and the silk screen also has a mistake on it. So
yeah, I'd also like to see them go to through-hole transistors for the 0.01 capacitors, the 0.01 capacitors. I'd like to see him go to through-hole on that. If he, I mean, it's double-sided and everything, so no real reason why he couldn't.
Well, I think we need to pull Ron back in onto this, and I'm sure. I mean,
yeah, or at least get hold of the design files.
He's got all that stuff. Yes.
Do you know? Did he do it on Eagle, or did he do it on?
TiCAD.
TiCAD. Do you know?
I honestly don't know the answer. He ended up with a bunch of files in a folder. We sent it off to some Chinese company, and they sent us back a whole bunch of really, really nice boards.
Okay. All right. So this is the first step, guys. I'm going to try and use this. And Dave, do you have a Nucleo where you can reach it real quick? Do you have one there? Yeah. And that it'll use one of those boards. So that'll be.
To get the board populated when you get it made?
I'm sorry?
Would it be possible to get the board populated?
Well, the board will be you'll have to, guys, will order your own board, because you'll have some possibilities that you might want. But if you want the one that we're using, it'll be, oh God, what was the one we ended up using the most? It was a 905? I can't remember.
No, I'm talking about the carrier board that you have to get made.
Oh, it'll be part of the kit.
Can it be populated with all the capacitors and everything on it already?
I don't know how the cat. It depends on. Right now, yeah. The intent is, is how. I don't think we can get the Chinese guys to do it without. I don't know what their cost would be. We could ask. I know there are companies that will do that for you. Okay.
Yeah, companies that'll do it very cost effectively.
Yeah. And that way we might put the headers on it and everything. Well, that's a good, Pat. That's a good suggestion. I might take a look at that.
That's a great idea.
The problem with this board, yeah, go ahead.
Assembling boards, most of the work is putting on those connectors, and it's about an hour or so job. We put on the surface mount caps. We put on in a toaster oven, and that was done as a separate step. But if that could all be done,
what do you call it? The transfer the paste onto the board.
Oh, a silk screen.
The silk screen, yeah. It's usually a metal or something, plastic silk screen that you silk screen all the
you don't need to do, on this one, I'm sure they just used something like a little syringe and dotted it. It's not that many, okay? I
Okay,
think
it's not like one per point or something like that, where there's hundreds.
1, 2, 3, 4, 5. I want to say there's about 12. Or
Oh, that's not bad.
or 12 or 15. So it's not really, it's dot, 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 dot. Bigger problem is putting them down on there, And Dave actually gave me some capacitors, and they were smaller than shit. I mean, God, those were microscopic. It turns out that you can get them bigger that'll fit, so a little less awkward. But I'd like to see, if we're going to redo the board to fix one line, then we might want to go ahead and see if we can get that to be through hole. But it depends. If we get somebody else to put them on, and it's only money, well, I don't know if I can still make your $175 budget, but I'll try. We'll
I'd
see
be
how
willing to
it.
go up to $200 if I didn't have to do the soldering.
Okay. Okay.
If it's
All
surface
right.
mounted, it's tough. It's I got old shaky hands, and
Yeah. Tell me about
One
it.
thing I'd like to interject is that if our goal is to make a club bot as a demo for other people to make it, and then they can just send us the code, we have to make it something they can get access to, all these parts. Off the shelf is good.
Yeah. Well, like I say, now that I'm thinking about it, I might be able to go to STI and get the actual Nucleo boards for free. I mean, it is a possibility if I approach them as the club and say, hey, I need, if I say we need 5 or 6, or maybe even up to 10, we might be able to get them for free. I'd have to see.
We're advertising them for other people to go get them.
Well, we'd have to have our project together. I don't want to.
Doug,
Yeah.
commiserate boards, do they do the same thing?
I'm sorry?
Are these commiserate boards the ones you're describing getting? That is, are they basically breakout boards?
No, that'd be the same one you just showed. The one you just showed.
In the plastic case.
Yeah, in the plastic case. Yeah. So, because that's
I'm confused. We're not talking about the. We're
talking about trying to get this remade, and the thought that came up that I'll have to explore is getting it properly populated. But this will have sockets on it. The board that you have, the one that you just waved up, would plug into this board. All right. That way, since it's your robot, if you own it, if you wanted to go to a different one, you could plug a different one in, and they're all downward scale appropriate, supposedly. So like if you wanted to go to an A7 as opposed to an M4, or if you wanted to use an M1, you could use an M1. So
maybe it would be useful for me to describe exactly what this board does. Is that already understood?
No, it probably isn't.
Well, basically, it just has sets of connectors on it. It's really just a breakout board. But what it does is it gives you all the pins for all the different registers, all the GPI pins and so forth, on that STM card associated with a power and ground. So basically, on the outside edge of each, you hold it up, the board kind of plugs into the middle, and on the outside edge of each there are 4-pin connectors, and it's ground, power, and then 2 signals. Those 2 signals are grouped together from behaviors inside the masks of the processor itself. So, for example, well, almost all our I/O requires pins in pairs, if you think about it. Transmit and receive, encoders, A and B channels, PWM and direction pins, and so forth. So they're all in pairs, and they're grouped by by their logical use.
Oh, I
Wish
didn't
I had
real-
the other one here. I can show you.
I didn't realize it was that sophisticated. I just thought it was a
It also
breakout board.
makes a couple of assumptions. One assumption it makes is that you're going to use a certain set of registers to drive servos. And so it gives you two different power connections to the board, one that powers the board, one that only powers the servos. So you can have separate servo power, which turns out to be something that you want. And then there are a couple of other sort of arbitrary decisions because it's a 5-volt bus, but the A to D converter is a 3-volt device, and therefore there's a 3-volt bus associated with it. So if you want to drive a potentiometer or something like that, you're already in the proper range. But basically, other than that, it's just a breakout board. And it breaks out. And my observation has been over the years that almost all the peripheral devices that I hook to need two signals, need power, and they need ground. And this board itself is really designed to have a daughter board, a shield, if you will, plugged onto it. And so there's just a couple of powers and grounds, which is all you need if you're actually connecting a whole other board. But if you're running out 10 or 12 different devices, IR detectors, motor drivers, servos, and so forth, then almost every signal needs its own power and ground. And so that's basically what this board does. It's a breakout board for any of those Nucleo boards that will fit on. Is that enough?
Question for you, David. Is it compatible with your 426?
Yes. Yeah, okay. Compatible with all those. In fact, if I can pick this up high enough, if you see over there on the bench, no, you can't.
Dave, I can give you a question. You can see it.
There. You can see there is one of the devices with the STM Nucleo. I don't know. Can you see that at all? Probably not.
Kind of.
I can see the bench.
So anyway, that'll be the main processor board. We might, like I say, it'll have some basic suite of sensors. Okay, you can expect, but you know, on your own personal version, you might want to add additional sensors to it, and you may want to do additional things. So I'm going to try to make the club robot pretty basic so we can compete. Now, does that mean that we're going to be stuck with this basic robot forever? No. What it means is we get a starting point, and everybody can then see, you know, we'll see how successful it is, and then we can add other more complex sensors to it. It probably will. I don't know how I'm going to handle the camera yet. Okay, we'll probably have a camera, but I'm not sure exactly how I want to handle that yet. We've used in the past, most of the ones that have used this have used something like a Pixie, but I'm thinking more like yeah, something like that. Yeah. Exactly. And so we'll see how that goes. So what that means is you would have something that you're probably programming, and if the well, depending on where we go, you know, we might throw, well, let's just get it basic to start with, but there's some contests that don't need a camera, but there's some that probably do need a camera. But I also would look at that MaxiPi board as an alternative because it's a little cheaper and it's pretty much a clone. Yeah, so, but anyway, that would be something that if we went to a camera. And the plans would be to go to a camera. But the first robot here, you know, we've got, we can do all of the simple ones like four corners, there and back, wall following, a whole bunch of those can all be done without a camera. And we can use that, we can have our first virtual, I don't know what, virtual with real robot competition will have that possibility. Okay. And we'll so anyway, just keep it in mind. If this is the first time you're hearing about this because you weren't here on Saturday, don't worry about it. We'll see how far I can get before, but I'm thinking it shouldn't be too difficult. And like I say, what we'll do is you'll have to build the robot. It'll come to you in a flat pack, and it's not going to come built out. It'll be flat, and you'll have to do screws and wires and weird stuff like that. Okay. So anyway, that's the second project that came out of what we were talking about on Saturday, and that we'll see how that goes.
Hey,
so,
Doug,
yeah.
I was thinking about Donna's issue where, she was having people send robot platforms, like the Zumo platforms. Couldn't she just have a couple Zumos and people send her whatever program they wrote, and she could load it up and run it against whoever else they wanted to be run against?
Well, that's another alternative, and we might do that too. I might look at this and say, well, the cheap way to do this is to just go buy some Bobots and everybody runs a Bobot or something like that. But that's not very interesting to me. So I'd rather redo this and get it going. But we might do that as to include to allow people to have different robot options, because what we really want to do is solve the problem of having people remote competing in the contest, and to have where they don't have to send us anything but a couple of files.
Right.
And if the robot, so.
Well, if Donna had two Zumos, she could load anybody's program.
So Donna was on the call Saturday, and she did say that sounded interesting doing it our way. She said they might not have the money or something like that to do it right now.
Well, I think they were
already done what they're doing.
Yeah, I think they had to. They're kind of committed to what they're doing next week.
Right.
But
so are we talking about this ClubBot's going to be an indoor or an outdoor robot?
This one will be an indoor.
Okay.
Outdoor is
more complicated.
Way more complicated because you have to be able to have some sort of. Well, you don't absolutely need it, but it makes it a hell of a lot easier as if you have GPS.
So version 2.
Yeah.
Well, and Doug, one of the things you're saying is it wouldn't be so interesting to you, and it might not be so interesting to a lot of people who've been building their own robots and have years of experience. But for a lot of people who don't have either a shop or the ability to build, something like a Zumo is very appealing. And in fact, in that last conversation we had, you kind of tuned me into that whole idea of using those little infrared transceivers to actually do a robot tank. And I'm actually going to explore that, because if we ever going to get a club going here, it's going to have to be something that is easy to get, is easy to replace, and the Zumo right now is top of my list.
Yeah. So, well, that's an idea, and we may go that way. The nice thing about buying a Zumo is I think they've got to max out at $100. They're not. Can't be any more than that. I don't know what they cost, but
they're not expensive. No.
They're not expensive.
It's the accessories you add to them that add the cost, but the base price is like something under $100.
Yeah. So, but we'll see. That might be a second option that we can do. But let me explore this, because this is going to be a longer thing, and a Zumo we can just order and say, okay, guys, for this competition, which, by the way, if I remember right, and again I'm going from my faulty memory, I think we said that the next indoor robot contest was going to be in November, wasn't it?
I thought that was an outdoor contest.
No, outdoor is in August.
Okay.
August. Now there might be, like I say, these virtual ones. There'll be we'll probably have one or two virtual ones in between. So, and like I say, this one I know it seems like, God, man, you can't compete all the way to November. Believe me, it'll be here before you know it. It happens, especially, I mean, since this is a hobby, time creeps up on you.
Actually, there's a study I saw a while ago that if they're under 30 and they go, okay, tell me when a minute has elapsed. Tell me when a minute has elapsed. And if you're under 30, a minute, they go, okay, a minute. They clocked it at like 95 seconds because it takes forever to get there, right? For us old people, we clock in at about 45 seconds. So things just come way faster. That's just a perception that I can't even. I'd like to quote you. It was pretty where it was, but it kind of stuck in my head. And I'm like, oh, that's why it took so long for Christmas to get here when I was 5 years old. Now it just shows up out of the blue. Got it.
Yeah. But anyway, so I think that's enough on that. And I'm going to make sure I check out the Zumo out option. That's I believe that's a pretty nice little robot for what it is.
I have one of those, Doug.
Yeah. What do you think?
Fit that with an Arduino on it.
Yeah.
And I just gone anywhere with it because I didn't have a line following maze to follow or anything yet.
Okay. Yeah. Well, okay. Pat, since you're kind of new on this, let me tell you this. If you go out onto the DPRG website and go to wherever the GitHub link is. So wait a minute. I guess you can just go to github.com/DPRG. It'll take you to a website. Okay, it will take you to a GitHub repository. In there's a repository called contests, and in the contest there's a sub repository called line following, and in the line following there are everything you need to build club style line following courses. And so like you can make and instructions for here in Dallas where you can buy them. I don't know if the shipping to Canada, but there probably is local vinyl companies, and you get it made at a vinyl sign company, and like for $2.5, $3 a square foot. So like if you make a 10 by 10, that's 10 times, and that's 100, so that'd be expensive. So, but I mean, if you have smaller courses, I know I've made courses for $30-$40 that have been fun to play. So you might take a look at that and see at that repository and see what your idea. There's official club ones that we used in the last virtual contest. They came from there, and then there's also a series of different test courses to test different elements. And I want to say the easiest one is simple rounded rectangle, and I think it's like 9 squares, so 9 times 2.5, $20. I mean, it's just something to look at. It comes to you in a tube. You take it out of the tube, you put it on the floor, put the robot on it, and you're good to go.
Yeah, there's a couple printing outfits in the area that would be able to do something like that if I had a file to give them.
Yeah. So,
And it's probably much cheaper than shipping it internationally.
Yeah, probably. Yeah. So I'm just saying that's something to take a look at that repository and see if there's anything there that tickles your fancy.
Okay, I'll have a look.
Okay. Yeah. Yeah. So, who's next?
I can go while I'm
Okay. Go.
Already talking. So I didn't get very much done on the robot this week. I'm still waiting on that ship from China. Well, I think they say it's landed in the country of destination, but I can't track it with Canada Post, even though it's a Canada Post number. There's nothing available yet. So what I've been doing is trying to teach myself Git, some sort of version control, learn how to use it. So I've got a Bitbucket account, and I've got it set up and created some SSH keys, and I'm able to go back and forth to do stuff. So now it's just a matter of learning, when do I commit, when do I put my changes up, that sort of thing.
Yeah.
So, and so that's what I've been working with that. And then the next one I've been working on as well at the same time is VS Code. I'm trying to break a little bit away from Arduino and the IDE and go in towards VS Code. And then along with that is going to come C++. So Arduino is a little easier than C++, but I'm going to force myself to learn C++ as well to be able to do stuff. So I started with that, just playing with some little STM32 processors, I think an F103, and starting with the normal stuff, using for now I was using Arduino and Blink, doing a Blink program. I've also done it in VS Code and been able to communicate through an ST-Link V2 to the board and be able to upload something there and have it work. So it's just a matter of learning how to do that better, learning how C++ works better, and then getting into some debugging tools with it as well.
David Ackley has a, if you go back through the website and just go through the news, but go backwards, somewhere in the last 2 years or so, Dave Ackley did a presentation, and the video is up on you can go either to YouTube and try to find it there. I think it'd be easier to find it on the website and just scroll back a couple of pages in the news. Okay, in the arc.
Hey Doug, one thing that I found on that, which was after I did the presentation, is that you will lose the ability to download into the module using the Arduino bootloader if you don't put in a setup for the UART. In other words, if you're not using the UART and you don't set it up, you'll end up having to reload the bootloader.
Okay.
Okay.
You follow me? In other words, even if you're not using the USB COM on the Arduino, you still need to program it as if it's there, even if you don't use it, with serial begin.
Oh, okay. So you're just saying all they have to do is it port 1 with the USB is serial, or is it serial 1, or do you remember?
Yeah. Well, I forget what it is, but anyhow, the Arduino, and you're going to use the USB that they've got, the USB serial. You have to put in a serial begin and a baud rate. Remember that up at the beginning of the setup. If you don't put that in
over USB.
Yeah.
Yep.
Okay. So in the Arduino setup, you have to put a serial begin and a baud rate. If you don't put that in there, so that you actually set up the communication for that, you can't get it to reprogram. So even if you're not using it, even if you're not doing any serial stuff, put it in the setup, or you will have bricked it.
Oh, you can still use the serial port method, can't you?
Pardon?
You can still use, what is it, the two serial, where you put the jumpers in the right spot.
Oh no, no, you don't need any of that.
No, but I said if you brick it, you can unbrick it.
Oh yes. Well, if you brick it, then what you have to do is essentially reprogram it over the serial port and put it in the bootloader again.
Okay.
Yeah, Dave, I've experienced what you're talking about. Where I didn't put in a serial routine in there, and loaded a program, and then when I go to reload a new program in, it won't talk.
Exactly.
There's a set of jumpers. There's a boot 0 jumper that if you move the boot 0 jumper over and you hold the reset button, when you plug it in on serial, it forces it to go back and reuse it.
I understand, but I'm just saying that if you don't want to have to go through that and figure out, oh shit, what have I done?
Yeah.
Make sure you put the serial begin in the setup.
In any of your programs, so that it'll open the serial port by default.
Yes.
Yeah.
Because it uses the serial port to do the programming. So if it doesn't know that to have a serial port because of the begin program, you're hosed.
Well, that explains why it doesn't work unless I put it into boot 0 and reset it to get it to go into the boot mode.
Exactly. And it wasn't until after I did the presentation and struggled a long time that I discovered that was the secret recipe.
Hey, Pat, are you using the STM32 IDE?
Yeah, I do have it loaded. I run Linux on my computers. I've got a computer here that's my work computer is Windows, but everything I do is on Linux. So the STM Cube IDE was available. I've downloaded it, and that's what I'm working on. It's just there's an uphill curve with that, with all the hardware abstract layer, basically parameters you have to learn to be able to use all the peripherals.
No, that's the whole point of the cube.
Yep.
If you use the cube, it will write that program for you.
It writes the initial code for you, yes.
Yes.
If you tell it what pins are doing what, you want these 2 pins as part of your UART, and you want these 2 pins as a pulse width modulation, and it writes up all the beginning code for you.
Exactly, yes.
Yeah.
So
anyway, there's another guy in the club called named Dale Wheat. I put a link to his website there. He went through a tutorial on how to use the IDE, and it was for the blue pill.
Okay.
The same part that you were using. Just to kind of get you started. You may be beyond that now, but I thought there were some pretty good examples in it. Is there? I think beyond that, I don't think anybody else in the club has done anything, have they? Doug?
I think that's the only tutorials that I know of.
Okay.
Yeah. David uses STI ARM chips all the time. David Anderson.
That's me.
Yeah.
Oh.
I don't put David A because how does that help?
That's true.
Yeah. Yeah.
There's two Dave A's rather.
Yeah, and Dave Ackley also uses them. Mm-hmm.
The environment, I just use a GCC cross compiler, which I run under Linux. So I don't use the Arduino IDE at all. I use makefiles and just the standard GCC cross compiler runs on my Linux machine and generates an X file that I download to the.
Right, so Dave doesn't use the cube, right? You don't use cube.
You're not using STM cube.
That's not true. I actually have all the code, and when I need a driver for something, I go pull that code over and make whatever modifications to it I need.
Okay.
But yes, I am using that. It's it's a
that's
whole
right.
mix. Go back through and look at their tutorials, which are for sort of a random assortment of processors that they were selling at the time, or processor boards. But there's a lot of stuff there. So if you need to know how to set up an SPI interface or something like that, they've got most of the pieces that you need already in place.
It looks to be very, very complete overall. There's a lot of stuff in there.
Mm-hmm.
Yeah.
So you're talking about using GCC. You know, you're going back to my HC11 days from the Motorola processors.
Well, I've got a HC11 cross compiler also.
Yeah,
Well,
that's I used to use, but that's long gone. It was a DOS-based thing, and
Well, I sent a message into the group about the Nuvoton MS51, which is an 8051 processor from the 1980s that's now in a little 3 mil chip. And I've actually gone ahead and ordered one of those in the SDK development environment for it. I think you can program it in either assembly, like 8051 assembly, or you can program it in C++, like an Arduino kind of thing. They've got a whole software development environment for it. So we'll see how that goes. I might be moving into David A's territory with this thing because it's 8-bit, and but I think it's 30. No, it's not 8-bit anymore. It's actually, I think, a 32-bit processor, but it's 8051 assembly. But yeah, interesting little boards. They're actually about this big. They have a board on them with a USB that you snap off after you're done for doing the programming. So yeah, we'll see how that goes.
So we never snap those off.
No, I wouldn't. In fact, the one that I bought, you'd have to cut it off. It doesn't snap off. So.
In fact, when I upgraded from a HC11, I went to the Motorola 68332, which is actually an excellent robot controller because it has that parallel processor that does all the timing I/O, that 16-channel timing processor that you can set up to do all kinds of things. And I stuck with that for decades after I was being teased by everybody else in this group for being stuck in the last century, millennia, really.
It was because his robots were the only one that still had a pull chain on it, where you had to pull it to start it.
It had a crank. You had to start it. So then about 3 years ago, Dave Ackley gave me, he just got tired of me being stubborn, so he just gave me a Nucleo board. Here, he said.
I can mail you a 68,000 if you want.
I've got them right here on the shelf. And so I actually spent quite a bit of time going through all of the available options, and I basically came around that I could do everything I wanted and more. I showed the guys one time basically a plot of the execution time of the process, running on the 662, and then the same thing on the Clio. And basically, all measurements converged on 0. All of the processes that were totally filling up 68332 take less than 1% of the processing cycle. I've got 99% of the processing cycle free on the STM32. So it's got plenty of RAM and lots of I/O pins and all this cool hardware stuff that you can set up. That hardware abstraction layer that Doug was describing is actually pretty useful because it allows you to swap out their product without having to change your drivers, which is cool.
Yeah, so that's what I was going through on a couple little tutorials on just blinking the LED and how to load the code, where to go in, and so going through the different sections. It's really nice when you use their tool to set up how you want the processor, that you've got your initial config file made for you. Mm-hmm. And you just go into the relevant sections and then drop your own code in there.
So yeah, so good luck with it. I found it very powerful.
Yeah, it takes care of setting up all those thousands of bits to make it do anything.
Mm-hmm. Well, it's on the book to learn. So.
Got a question for people who have used the Zumos. They have all different gear ratios. Any guidance on what's the best gear ratios to use?
Well, I think it depends on what you're trying to accomplish. If you're trying to do literally a Zumo competition, you want to be able to have a lot of torque, or that's sort of a competitive edge. But if we're more into like exploratory robots, you probably don't want the fastest one out. I've got an order that I haven't actually fulfilled for a 75-to-1, which I think is right in the middle of what they're recommending.
I think that's what I've got, and it does a little over a foot a second, I think.
Pretty fast.
You're saying the 75?
Yeah, that's the one I bought. It come as part of I'd already assembled essentially with
Yeah.
An Arduino interface and 75 to 1 motors.
I think, Dave, you may remember, I'm not sure, but I had a conversation with one of the Pololu people like last year sometime about trying to figure out how to get encoders onto a Zumo, and the plastic container that holds the batteries and the basic frame, the chassis, doesn't really have room. But he actually sent me some files, some 3D files showing how you could possibly cut certain parts of the thing away to get one of their 3 different encoder style attachments on the back of the motor into a Zumo, but it's pretty tricky. You'd have to get out a Dremel and cut out some of the plastic to do it.
Would you be willing to share those files?
I can find them, yeah. Yeah, I'll see if I can find them in my email, or I didn't throw them away, so yeah, I'd be happy to.
Okay, thanks.
So it depends if your style is either bulldozer or duck.
Yeah, I'd appreciate getting a copy of that file.
Okay, I know that there's 3 styles of encoder, of Hall effect encoder. One of them has a little tiny printed circuit board that has just you solder wires to it, and then there's one that had the motor coming out this way and another one coming out this way, and I can never remember the name of them. But there's 3 styles. The 2 that have the connector rather than the solder connections are pretty handy because you just have a little, I think it's a JST style connector to it, and for like, I'm thinking about using it for that Mecanum robot, so I'll end up having 4 motors and just not having to solder that many, and having a little more of a being able to disconnect it easily is kind of a nice handy thing on the encoders, because it actually attaches the motor and the encoders in one connector.
Right, but your file probably only that he suggested probably only works with one of them.
Yes, that's correct. He looked at the 2 different ones that have the JST connector and figured out which one of them was possible, and then he went ahead and modeled it and then sent me the model.
Could you put that up on your website?
The wiki?
No. Well, you can do that too, but I was thinking robotorgs.nz somewhere where we could get.
Yeah, I've got a.
If you
I've got both the blog and wiki there, so I can put it up on the wiki and make a page, and then I'll publish that to the mailing list.
Cool.
Okay, thank you.
All right.
Very cool.
Since I'm already gabbing, David Anderson knows I've got a new project. I had put aside the Mecanum robot until Carl works his way through the difficulties he's had with Mecanum, and I figured that since I had made the front sensor, what I call the integrated front sensor of my main robot, detachable with 2 bolts and an I2C connector, I decided to go ahead and try to make a differential robot using that same thing. So that's what I was running away. I went downstairs and I cut this wrong, so I can't put it on. But basically, I've got one of these OSEP wheels on a big, heavy caster, and that goes on the back, which I won't be able to attach now. But this is basically the differential robot, still in progress. But I've got the same OSEP motors, encoders, and wheels as I do on my main robot, which, for those who haven't seen, is sitting with a fan on top of it over there, because it's actually hot in New Zealand today. So this is my KR01, and it's missing its front bumper right now, and that is now residing on the front of this robot, and then I'll put that caster on the back, and then it'll be running a Raspberry Pi. I've got my Thunderborg motor controller here. The bigger robot runs on 18-volt Makita batteries, and I've just put an order in for a 12-volt 4 amp hour battery that will fit right there. And so basically this is like it's not really a much smaller version, but it'll be a differential drive version of my other robot. Use the same code and everything. So it's kind of a simplified project that gets me into differential robotics, where I can have this thing actually rotate in place on a table and not fall over, the way David showed us how to do, 6 years ago or something like that. So I'll see how that goes, but it's my first attempt at a differential robot, but I've already got the sensor already there, so that's kind of handy. But that's my big project right now. So I had to do some hardware. I was really getting itchy to do some hardware.
Can you hold up how those 2 fit together?
Oh yeah. You mean this part?
Yeah.
Oh, okay. I cut it wrong, so it won't actually fit. But basically, I'm going to have four little uprights, and then this will fit like that on the back.
Gotcha. Okay, thank you.
Yeah. And I thought about just making a balancing robot, but that'd be kind of tricky. Anyway,
Okay.
yeah, that's it for me. Like I said, I've got an order in for the Nuvoton processor, and I've been goofing around with all sorts of alternative processors to a Raspberry Pi. Basically, that idea of having sub-processors like Arduinos or Itsy Bitsies and all that, offloading some of the sensor processing tasks to other processors and then communicating with the Raspberry Pi. I mean, I've done that with these little, with one of these. This is a Nuvoton MS51 on the back there. You can see it. I think that little black square. So that's a I/O expander from Pimoroni, and that's what got me into this thing. So now I've got an actual board on the way. But of course, the big question is how to communicate with these things. One of the benefits of this I/O expander, of course, is that it's already set up with a library, but it's a little on the slow side. Like what I found is that I typically get a turnaround on a call of like, I don't know, 50 or 60 milliseconds, which seems really slow. And so I've tried to program my way around that by not relying on high-speed communications. But, you know, communicating with an Itsy Bitsy or communicating with any of these, it's one of these things where if I'm calling it 6 or 7 times for each of the sensors, and I've got 5 infrareds and 3 bumpers, that means I'm making too many calls, and I need to consolidate the call and just make one call, and then it's 50 milliseconds for one call. So that's how I've kind of got around the time delay. But this whole thing about working with subprocessors is quite interesting. It's, I guess it's how everything's done. It's just that usually you don't have to do it yourself with these little I2C processors or sensors. Anyway, that's it for me. Blah, 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 blah.
John, you got anything? John.
I got something.
Oh, you got something? Okay, David.
This is something for Jean. We talked last week about using those L298N motor drivers, and I showed you some data, and then I decided that I should actually go back and look at my code and see if what I told you was correct, and it in point of fact was not. Everything I told you was wrong. So
this is about the starting the motor, like the transition.
Yeah, so teach me to try to wing it. Okay, so here's my correction. The one robot that I actually do use that little L298N, the board that you showed, the very board that Doug wrote the code for. And according to his terminology, the code I'm doing does the drive and coast. What's your terminology?
Drive and coast mode, yeah.
Sign magnitude / coast. Or however that's the code.
Well, it's I called it drive coast. It is a variation of sign magnitude because if you think of it, you're providing the sign, you're providing the magnitude. And if you go out on the internet and you start to try to find the name, there's lots of different names. Some people call it sign magnitude coast, like you did. Some people call it other names, but in my article I just called it drive coast because that's what it does. You know.
Well, that's the actual function on the robot, the one robot that I'm using that does use that driver. And let's see if I can present for a moment. The second thing I told you was wrong was that robot actually does use a lookup table to linearize the PWM response. Mm-hmm. And what do I say? Present now, my entire screen.
Yeah, and you have to click on the little on the screen too. There you go.
Yep. Do you see a little graph?
Yeah. Yes.
All right. This is the motor table, the motor lookup table that it uses to linearize the PWM response. So that's the second thing I was wrong about. It does actually use a motor lookup table. And then the third thing I was wrong about, which is the most egregious, is that robot only uses a 200 hertz PWM.
Interesting.
So basically, everything I told you was wrong. I just wanted to, do a complete repudiation, mea culpa here.
David, a quick question is, when it's stopping and turning around, you're just relying on the PID to bring the speed back to, well, reverse the speed, right? To like positive, then 0, then negative. Because there was a jump in the speed profile, if I remember correctly.
I think that jump in the speed profile that you were showing us last week, where you didn't on until you were almost at 50%. Is that the jump?
Yeah. Like for me, there was a dead man. I think I saw in your record there was a speed versus time, and there was a jump, like it snaps to 0 and then snaps back to a positive.
Well, that, as I say, that I was showing you was from a completely different robot and a completely different intelligent motor controller. So ignore all of that. That was all wrong.
Too many duets.
Yeah, but I think what David would agree with is that if you've got your PID set up correctly, the deadband won't be, you can get rid of the deadband, because what it does is when you don't talk about it by saying, I want to set a speed. What you tell it is, I want to change, well, excuse me, I'm using my terminology wrong. You don't want to say, I want to set a PWM value of 20. What you say is, I want to set a velocity of 2 inches per second or whatever, and the PID makes it go that speed. All right, so like I said last week, was the real test of your PID is going slow. If you can go slower, then you can make the motor normal. Otherwise, let's say you have to you have to give the motor controller a PMD value, PWM value of 50 to have the wheel to start turning. Okay? And let's say that no control, just giving it PWM of 50, and that's where it starts to turn. All right, but now if you figure out how fast it's turning at 50, okay? All right, and you tell it to go slightly slower than that, it should stop, right? Well, as long as it's turning, your PID will, if you tell it to go 1/2 inch per second, it really should be able to do it. Okay, now it might not be a smooth, it might be a jerk start to get, to get up the speed, but so like it'll do something like this, to get going, but it will run at that lower speed.
Yeah.
That's what made me wonder. If that jump on you were seeing, which was quite pronounced, that is it caused because you're trying to drive that device at too high a PWM? You said that your choices were like 40K, 32K, and 1K, or something like that. You didn't have a lot of choice. And it did look like the 32K worked better. And that's what I thought I was using. But when I went back and looked at the actual code, this one's using a 200 hertz PWM frequency.
Yeah, and I want to say that
I'm not.
the other thing
So
that
if you try a slower one, maybe that weird jump on will go away.
Yeah.
Maybe can I quickly share my update?
Okay.
Take this opportunity. So last week was pretty busy, but maybe I can share my thought. Before I got into this, this PWM frequency issue, I got something working. It's like I have 4 channels of feedback, and then my intention is basically my PC, or I want to control from a host like a PC, tell the controller to control 4 wheels, and that 4 wheel would have a motion profile. So initially I was using position, because my logic was, well, position and velocity is just a derivative. so if I give it a motion profile, basically I say say I have 10 points. Each point is like a count for the interrupt, and a position, like a count for encoder. And then the interrupt will keep going, and it will tell the feedback where the position should be. It didn't work well, because what I see is, because of my, the deadband, it basically stuck and go, so it never settles on that position. Now I'm thinking, I mean, I haven't tried it, but what I'm thinking is I'll use a speed feedback, because it worked before. Basically, the speed will be a constant value, and with the PID, it should really settle at a constant. With the position, I guess it's...
Now, one thing that you remember we told you that it might not be a smooth start, it might be a jerk stop. Well, if you've got it set so that, let's say you're stopped, and all of a sudden it goes to 250 to get moving, okay, and then it moves faster than you want it to do, and so it slams it to 0, so that, because it's saying, oh, I got too many ticks last time, so now it slows, and then it's basically stopped, and it comes back up, because now it's saying, whoops, and you missed my target again. Is this what you're getting?
That's right. So I have a linear curve, and the feedback is really following a position, which is a line, it's a slope. So it would go like, like fast, like overshoot, and then stay, and then overshoot and stay. But I really think the logic of following a moving position doesn't sound right. But on the other hand, I don't know what, I mean, if I say, my robot would move exactly, I mean, for example, it's like a stage. I had experience, so I want to make my robot kind of like a scanner, right? So before, when I control the stage, I say, well, go to X, Y. It will go there. And I want to have the robot do the same. Now, I'll have to try, but what I'm thinking is, if I tell it to move at a certain speed profile, and it doesn't go exactly at that look, I mean, I imagine on the way it will keep accumulating position error. Maybe at the very end I switch to a position feedback. But I don't know. I'm not.
Well, okay.
I don't know how.
Yeah. Go ahead, Dave.
John, if you remember from those profiles I showed you last week, which I said were wrong because they weren't from that particular motor controller, but if you remember them, basically the acceleration ramps are all linear, and they are actually ramps of velocity. But the deceleration ramps are, I don't know what you want to call that, exponential. They're curved. And the reason they're curved is because they are position dependent. Basically, the speed is derived from how far away I am from the target. So as it gets closer to the target, it slows down more, which means it also gets more samples per inch or whatever. So the up ramps are all linear ramps, but the down ramps are curves, and they are derived from position. Now, I've got two different things running there, one of which is there's a PID controller which just controls velocity. The other one is there's odometry running, and there's a navigation process running, and that navigation process knows how far it is to the target, and therefore can send a command to the motor controller for a speed based on essentially how far you are from the target.
is this at any time there is a target, but you keep updating that target based on the position difference?
Right.
Ah. How often do you update that target?
The robot's position is recalculated 25 times a second, so every 40 milliseconds. And so when the robot knows its position and its heading, it can then calculate the distance and angle to the waypoint. So it does that every 40 milliseconds, so 25 hertz.
I see. Okay. I think if I fix it to follow a speed, not a position, I'll be in a much better position.
Okay,
So,
now there's one other little trick here too. If you're setting your speed, all right, you're setting your speeds to try to go in a straight line, basically. All right, but you're not really going to go in a straight line. You're going to go close to a straight line, but you're going to be off. So your heading is going to be off. So you have to wrap around the speed a heading correction, and it usually just has to be proportional, so that what your reference would be 0. All right, because your reference is your heading, okay, your desired heading. So if you drift away from that, then you'll be proportionally pushed back towards a straight line. All right, so it's not just pitting the wheels, but you also have to have something that handles the angle. And then, like David said, you use the odometry to get your actual position. So, like, let's say you wanted to go 10 inches, but when you get 9 inches, you don't want to be going full speed. You want to start slowing down.
Yeah, I see.
Okay, all right.
Yeah. Cool.
David, do you deadband your position, your waypoints? Like, say you get to a waypoint, is it plus or minus a few counts?
Say that again, Ray. I didn't quite catch it.
Do you deadband your waypoints? So, like, if your platform gets to the last waypoint and it overshoots, will it back up, or is there dead banding?
I see. That depends on how much it overshoots, how much it misses the target by. But basically, when the robot, just to follow on from the point I was making to Jean, when the robot is cruising toward the waypoint, but it's more than a certain distance away, and I think that currently is like 25 inches, then it just tries to run at full speed. Once it crosses that 25-inch circle, then it scales its speed by the distance to the target. And the target circle is a 1-inch circle, the target circle itself on this robot. And the rule says that even after you cross the target circle boundary, as long as you're making progress toward the waypoint, meaning that this distance to the waypoint was less than the last distance to the waypoint. As long as that's true, you're still getting closer to the center of the circle. But as soon as that's no longer true, you've either passed over the center of the circle or you've been deflected away from it for whatever reason. And at that point, it declares victory and says, I've arrived. So it is possible that it could get right and center on the waypoint, but it doesn't have to. It has to stay within. It has to be within that error circle. My outdoor robot, that error circle, I think, is 12 inches. So it's got to be within a foot of the outdoor target. But it does the same thing. As long as you're going toward the center, it continues. But as soon as, for whatever reason, the distance is longer than the last distance, then it says, I'm here.
That waypoint does not have a time, right? It's like it'll figure out how long it wants to take to go there. You're not telling it to go how fast.
You tell it how fast to go.
Basically, it tries to go full speed when it's outside of that large circle, the 25-inch circle, and it slows down within that circle. But this is all running in a subsumption stack, and the navigation is a very, very low-level, low-priority task. So if any higher priority task, like a sonar or an IR avoidance task, turns the robot away, when all those tasks stop running, then the navigation takes over again and turns it back toward the target. So I can't set a time because I don't really know when it'll be there. Depends on how many things it has to dodge on its way.
Yeah, thanks. Also, I want to say, Doug, thanks a lot for the two things, for the motor drive explanation. Those current flow really helps with the coasting, meaning, and the braking.
Yeah.
Also, this club robot, yeah, I think that's a great opportunity.
Okay. All right.
Follow.
All right. Well, like I said, next week I'll give you some more progress. Hopefully, I should be able to figure out, what Pat, what is it going to cost to have them stuffed. And that's. I won't, I won't tell them to put the nuclear board in. It'll just be all of the sockets that you need for it.
Yeah, sockets, if through-hole components aren't a problem. It's a surface mount that tends to be a little tougher as you get older.
Yeah.
They don't make a surface mount component would need to be about the size of a penny so that I could solder it. Something I could use a torch with.
There you go.
The old
You
thing
know,
about
this
too damn big,
the toaster oven that the guy at work did for me actually works real well. He painted a little bit of that solder paste on all the connection points, and then just kind of stuck the caps down with some tweezers. And then as the solder paste heats up, the little caps kind of float over into position and square themselves up. It's actually pretty.
Surface tension.
Yeah, I've seen a few people do that. There's a cat on Twitch his name is James. He works for Element 14 as a marketing person, but he calls himself Bald Engineer and does a bunch of stuff. And one of the things he did a few years ago, and he just rebuilt, is a reflow oven, and he was showing how that works. And literally, I've got a bunch of boards. I got a few boards over here, so I can practice doing all of that. They're little bitty. They're like $2 boards of things that has lots of LEDs and other things in there. And if you do it all right, they like flash and sequence around and that kind of stuff. But so I was going to play on it, and I was watching what he was doing, and when he does it right, it just he got his own board up there. They sent him a mask for it, laid it on top of it, literally squeegeed over the top of it with that paste that you were just talking about on there, and that mask put all the solder paste in all the right places, and it's just sticky enough to hold on to the various components, and he got them on there. And when he put them in the reflow oven, as you watched it, because of the nature of physics and that stuff heated up, they just snapped into place like they were just magnetic. It's really.
Well, I'm totally with Pat on this one. When I first got those parts, I looked in the plastic bag and I'm going, where are the parts? No.
Yeah, you're picking them up with a pair of tweezers with a great big magnifying glass in front of your face, and you're trying to put them on the board, and you're shaking all over the place.
And that's part one.
Yeah.
Anyway.
I need another 100 capacitors. Like 30 of them on the board.
Yeah.
Yeah, there's kind of a weird effect. It's called tombstoning. Like sometimes even though you have solder paste on both ends, for some reason the tension will be higher on the other end, and it'll flip.
Yeah.
Upright.
I've got one just out of curiosity for you guys. So I got a new pair of slippers, and I'm walking around up here. It's northern Ontario. It's dry in the winter, so it's about 31% humidity in the house. Well, last couple days with these new slippers, everything I touch, I zap. Everything. I'm deadly afraid to go near my robot. I don't want to touch this.
Yeah, I know what you mean.
So,
yeah.
I don't know if you can see that. Mm-hmm. I put a copper braid into my slipper.
Yeah.
Desoldering wick.
Yeah. Did it work?
It worked.
Fantastic.
Yeah. Wow. Cool.
I don't rocks today.
Yeah.
Send a patent application into the U.S. Patent Office and get that going. That's like you make $1 million.
There's no other hobbyist group on the planet that has this information.
Well, you know, I hate to bust some bubbles, but back in the mid '90s, and I was working for a place called Convex Supercomputers, and we had to go through ESD training and stuff, and we built a bunch of stuff with a bunch of pick and place and wave starter machines and all that kind of stuff. And because of where I was, I sometimes needed to go on the floor to debug some software or whatever, because we could use machines that were in the process of being built to debug the machines that are out installed wherever they are. You know, you got $1 million machine, you're not shipping it back to fix it and putting out. You're looking at new parts and fixing those things. And we had to go through all ESD training and that kind of stuff going on, and especially in the winter, they had all signs everywhere. And basically, that's exactly what they did. It's a hill strap you put on the bottom of it. They've got a couple of tester things before you go in the area that you have to make sure you get a green light on that before you walk in. That's exactly what they did, where they had those metal, or it wasn't metal, they were cloth, but they were impregnated enough so they were conductive as you were standing up around and doing all that.
Still a cool idea, Pat. Still a cool idea.
Yeah, I got it. It was, my wife reminded me that in the 70s, they used to hang the little copper plastic braids on the back of the car.
Yeah.
And it got rid of all the static.
Yeah.
Pat, the only thing is, you know, now you've got this excellent, you know, path between your feet and ground.
Yes.
Not touch that black wire on.
I'm an electrician. I've learned not to touch the black wire.
Yeah,
Okay, 120 volts, you hurt your elbow.
Yeah.
As you're pulling away. At 600 volts, you tend to drop a load in your pants at times.
Yeah. Anyway, the nurses used to do that in hospitals because, you know, you have oxygen and you don't want the static, you know, electricity to light off an OR or something. But the, you know, the same sort of thing, if there was any ungrounded equipment, you could electrocute yourself. Because in a lot of cases they had, you know, the floors with the metal straps in them in the ORs. And, but yeah, so you might want to consider using something higher resistance than copper, electrical resistance. That's what
You got what you use, eh? I went in the garage and I found some desoldering wick.
Yep, yeah. Like I said, just stay away from that black wire.
Yeah.
Nasty one.
Most of my work nowadays is all PLC programming. So.
I see that we have somebody on our thing called Dallas. Do you have anything you want to say, Dale? Dale? I don't know if he's there. He's not videoing. Okay. Anybody else?
Yeah, the eyeball.
Yeah, I was wondering if there was anybody else. John, have you said anything? John K?
Yeah, but no, there was nothing additional other than I would say one thing I want to comment was, I don't know, but, you know, regard to building the robot, you know, the simple one, I would do a simple one, and that's why, you know, this case I did 3D printed at the top for the benefit, and then next week, actually, I'll probably show you, I found another website that might be of interest to look at for just information. So let me move that to the web. Okay, where do we need to click? No, I don't want that button. Okay. There we go. So this instructable I found that's sort of interesting, so y'all might want to look at that as another possible ideal. In other words, it's taught effectively to make a robot. And let's see if I can click on the presentation to give you that. Pick a window. Hopefully. Yeah, I think that'll work. Hopefully I got the right window. So, but it looked sort of interesting that they basically did a Mars robot. And the thing that caught my eye mostly on it was down here that they use a Raspberry, and then they use a computer somewhere down on the toward the bottom. Yeah, they use a Raspberry camera, and they talk a little about setting up the Pi, and then the code feedback to a computer. In other words, they basically use 40 meter connection for a modem to a computer, and then that was sort of their string that they have. And this sounds like it's very basic code that could be easily modified to enhance. So that's another one y'all can look at as a possible thought, because yeah, the program simulates basic commands, so it could be expanded.
Using Wi-Fi, right?
Right.
Yeah.
So that's why I'm thinking it's sort of interesting, because we all have computers, and then it's just a matter of Raspberry and camera. And I even have a Raspberry laying around somewhere, I'm thinking.
Did they 3D print the parts? Is that what you're saying?
Well, the base is sort of, yeah, I'll go right there. Right there are the spots where they 3D printed.
Oh, wow. Quite a bit.
But they use some pipes too, so you don't have to really 3D print it. In fact, somewhere in here he talks a little about that fact.
I wonder if it's only working on the local host or if it's working on the internet.
Well, I'm thinking once you get to the local host, then you could spit it out. That's what I was thinking.
I thought that too, but I was looking yesterday that you had to make some changes in your router to get out of your own network into the internet, which might make that a little bit trickier. I haven't fully finished that yet, but I just started. I was half asleep last night making notes.
More than likely, what you've got to do is you got to make a way for your local non-routable IP addresses to be available in the outside world. And there's a bunch of ways to skin that particular cat. I would recommend that unless you really know what you're doing, you do not do that to your router. If you want to get through that, what I would do is I would look around. It's been a while since I've looked. I know they exist. There's HTTP redirects and that kind of stuff where you can do it in a more secure way, where you're throwing information through an not anonymous thing, but HTTP traffic already goes through your router in the same way. And there's ways you can use an external third box out there. There's people that sell this service that do this, so you can hit that inside there and be relatively assured that you're still okay inside of your home network and that kind of stuff. So I'm not saying don't do it, but you need to read a lot about it before you do that, because it's basically, if you've done it just a little bit wrong, you've opened up your entire household to whoever wants to come in and whack on you.
Yeah, we don't want that.
No, you don't want that.
I have some experience having
just network address translation. That's a source network address translation, which would change the source address on the way out and then would change it back on the way in. So there's not really any way for anybody who's on the outside to connect like that.
That's what's going on right now. You're doing that already to go in the in, the out. But if you set it up the wrong way, it has to be a two-way thing. So if somebody hits a right thing on the right port on the outside, it goes right to that port on the inside of your network. And if you just mess it up just a little bit, you're able to or there's something on the inside of your network that allows them to get a foothold into your network, and at that point your whole house is wired up.
Are the connections that you need to be made ones that need to be initiated from the outside of your local network? Is that the problem? If they're only going to be initiated from the inside of your local network, then that's not really.
The reason I brought that up, I was thinking about our telepresence robot and having Murray in New Zealand connect to it. So he's got to do that over the internet through public IP. It can't be just local host.
I have some experience.
To a web server, as I understand the schematic, he just connects externally to an HTTP server.
Right, but that HTTP server has to be visible. You have to know the IP address.
Well,
Yeah.
Can I share some
I think
something?
I know where John's going to go with this. Basically, yeah, you connect to the external HTTP server, but the internal robot also connects to that external HTTP server and gets its commands from there. There's no direct connection between the two.
Right. That's actually one of the two ways. If you were reading fast, you would have seen that on that document I showed at the beginning. But I think that was a lot more possibility to be a latency, because the user has to send something to the central server, and then the robot has to be polling the central server looking for an answer rather than directly connected, sort of like an RC controller.
You're going to get latency anyway. You come from Australia, man. Light only travels so fast.
Well,
to have long latency anyway. This should be, this should work all the way to Mars, right?
Right.
My understanding is that the speed of light is actually much slower in the southern hemisphere.
Yeah, well,
I keep picking on Murray as an example, but there's also Chris in Chicago or Pat up in Ontario. It's very, what I'm getting at is outside of the local network. It was the whole point of the telepresence robots. So,
well, ideally, what we would do is to actually share, some keys, SSH keys, because that would be the way to do it properly. And then we would just out of band share these keys, and then you couldn't connect except through these keys.
Yep.
That's a little more complicated, but I hate to say, for those of us who've been using GitHub for a while, it turns out that GitHub is changing their policies, and it's not going to be password only after like July. You have to go through keys. So everyone who's on GitHub is going to have to learn, if they want to commit, how to use normal SSH keys. And that could be the way we do this, because then it's entirely secure.
Yep, and you can set up tunneling, roll our own VPN sort of thing, that kind of stuff, tunnel over SSH. There's all kinds of fun things like that you can do.
Yeah.
Well, that's more complicated than I was meaning.
That's the kind of stuff I was researching last night.
It's possible. It's like you're opening a web page from your browser. So basically, you can stay inside and reach out, and there's going to be a connection established during this. I tried this ESP chip with the Wi-Fi. So what I did was basically that chip will go to a cloud address and open the page. It can get the page back. Probably there's other way, but when I look at the code, it's really like there's an IP address. It's gonna reach out to the IP address. The server will open and will send something over, or receive some, like exchange some information. So when I look at that code on the C++ side, it's really literally open the pod and send some information, receive some information back.
Right.
Close the pod.
But does that activity give the server your public IP address so that if
well, I don't know if the server knows, but I guess if that's I guess you have to trust the server, but if it is a secure server, like the HTTPS, I think the connection would be secure. So.
Yeah, I understand that part. I've used HTTP gets and post to transmit data with a RESTful API, which I think is what you're talking about. But the problem is that would be, in this case, the robot talking to the central server, but still Murray doesn't have a way back to my robot from that. He can talk to.
But I think you can at least periodically reach out and get information back from the server. So yeah, it's
right. You have to be the server looking for the information, which is one way to do it.
But what if you open that connection and don't drop it? I think it's possible. I mean, I look at that code, it's like it opens the connection and it can send and get data.
Yeah.
It's just like sending TCP/IP messages.
Exactly. I was just starting to look up TCP/IP to see if I could open a port and send those messages and give them my IP address so that they can get back to me. If I can give them the public IP so they can get back to me, everything's solved.
Yeah, I think normally the server like this connection to be, I forgot the term, but it's like it's like no memory. So it's like go and open, get information, and close the connection. But I
Right.
really think if we want to keep the connection there, it will work.
Okay.
If the two
I'll be
sides
doing
don't
some
call.
testing in the near future on that kind of stuff.
On the receiving end, wouldn't you have to open a port on your router?
That's what I was trying to get. Actually, I've read that you can do that. You can put an Apache server on your Pi, easy peasy.
I know.
Local host.
You're opening your network to the outside world.
Right, but then
it's like the host is on the
get into all
cloud.
those things that Harold was talking about. You better be real careful, or all the Russian teenagers.
Host is on the cloud. Then that cloud needs to worry about people reaching it, but your device doesn't. I don't think your device needs to worry about letting people find you because you are reaching to the cloud server.
That's one way to do it.
Yeah.
Murray, you're talking, your lips are moving, but you're muted.
You guys are trying to solve a problem that's been solved like a million times before, and that's if you're going to use HTTPS, don't go down to UDP, don't go down to TCP/IP. You've got HTTPS, which is a secure protocol. You can use all manner of ways to secure that. But once you set up a transaction on HTTPS, let's say using a simple password, that is now a secure transmission protocol. And so if you want to set up, if we're talking about using, let's say, web servers or HTTPS, then there's hundreds and hundreds of libraries that can like either password or SSH key to give you a secure connection. And once you've set up a connection between the robot and the browser, it's like when you log into Amazon or any commercial site, you've got yourself logged in, you're on a secure connection, and it's as good as anything out there on the web. So don't go find another protocol. You've got one.
That's the easy part, but then letting Amazon get back to you to give you a command is the hard part.
No, that's actually set up in HTTPS. You have a two-way protocol, basically. It's like when you're logged in, like you're talking RESTful, I can make a password set up to a RESTful server. Once I'm logged in with a browser or a robot, it's now a two-way protocol, push, post, get. It's all there for you. You don't need to invent anything.
And you might want to take a look. This may, it's going to seemingly complicate things, but not. Okay, you want to look for something called Signal R.
Yeah.
SIGNALR. Okay, it's based on WebSockets, and this would be a good solution for anything outside the world. So you have a web browser setting out, a web server setting out in the cloud, doing whatever it does. It holds something called a Signal R hub. You have a client. A client can connect from anywhere, and of course we can secure that client, authenticate it, all those sorts of things, right? So what happens is it's a hub like your network hub. So as you send information and messages into that hub, it rebroadcasts it to the other clients, and one client can talk to another client. And now that's a WebSocket. That's a long-running open connection for web that is secured with SSL, just like Murray was talking about. But it's a secured, long-running connection between the thing. They can, if you drop it, it can bring it back up, and your robot that's protected inside your nice, safe place in the internet can reach out and connect up to that hub in a secure manner. Murray or whoever else connects up to that hub in a very secure manner as well, and all the messages that go between everybody around that thing can go on. And it has the extra benefit that if Murray connects up, Pat connects up, and Chris connects up, because everybody sees all the messages, you can see that Murray's doing something so Chris can't, or Chris is doing something and Murray can't. It'll see all that kind of stuff. So you want to look up for a Signal R hub, and we can set those things. It's a Microsoft. That's what Microsoft calls their product, but basically the generic term of that's WebSockets, and it's a way around that. So I would put that into your search terms and look at and see how that works, because that would solve every one of these problems here. And what we do is we use HTTP clients to connect to do all our message passing, just like Murray was suggesting.
Cool.
Well, Murray was suggesting SSH, but the still the same kind of idea that he first was.
I translated it.
Yeah,
I was suggesting something a lot simpler than what Harold was suggesting. Just simple UPS protocol that's been like there's
Agreed. I'm sitting on top of that so that we get more of a thing. But this is something we can always add to. This is not something we need to start with. We can always add to this thing. And it's
Right.
actually pretty cool. We're using it on a couple of my clients that I'm working on, and for updating. When I first saw this 5 years ago, it looked like magic. Somebody's picking up an object on a web browser, and he moves it, and it moves in Google, Chrome, and Firefox at the time because they're all open in the web sockets, and it looks like magic. It's pretty amazing. I thought it was. And now it's like, oh, file new project, signal our project, make a hub, and go with these. There's some configuration to make that happen. But yeah.
Doug, are you researching for this
Right.
telepresence?
Telepresence API that we started off talking about?
Yeah. Doug E, he was talking about coming over here to this meeting. But anyway, I wonder, maybe we should meet together and say what's like the minimum feature we have. It could be send one command and so that our Arduino receive that command. But I think we can talk together at some point and define
Right.
like something we can verify.
Right. I think you and he were on that chart as being working on the UI part, weren't you?
Yeah, but when I think of UI, I'm thinking maybe I just need to post a message to a web like a HTTP post,
Right.
or maybe each HTTP get,
Right.
which I can use for a web browser to use. So I don't know. I mean, I think we should really talk together before we explore.
I just posted a link to the SignalR thing I was just talking about, and that sample is a real-time text chat working over 2 different web pages.
Cool.
Okay.
Thanks. I've moved that to my notepad.
Yeah. Hang on to it. It's probably not something we want to do initially, but it's something you'll probably be aware of because we are respectively passing messages between all of this stuff, whether it's an HTTP call and waiting for a result or something else kind of that way.
Yeah. So, I don't think I was explaining what my problem was correctly, but I think that was the answer. For phase 2, phase 1 was exactly what Murray was talking about, where you just make the RESTful call to the central server and the user makes the RESTful call and the server is the client in the middle. But that one's going to be slower, and I think it may have some problems. We'll see.
Well, I want to reemphasize, though, if the point of telepresence is that the speed of transmission shouldn't matter. If it takes 7 minutes to get there like it does on Mars, then that's fine.
But if you're trying to move the robot over to look at somebody's conversation, you kind of want it to get there a little earlier.
Well, my understanding is it's about a 400 millisecond delay from New Zealand to Washington, D.C.
Right.
So, 400 milliseconds. Yes, a robot can go a long way in 400 milliseconds, but only if it's going pretty fast.
I'm probably, I tend to overthink things sometimes, so I'm probably dogging it. I didn't want the robot to be spending all its time polling for what's my next command. I wanted you to be able to just tell it directly. But maybe polling isn't so bad.
Well, and again, the robot should be autonomous for at least 1 second.
Oh, yeah, it's got to be autonomous. But most of the time it'll be autonomous just waiting because that's the last thing you told it.
Yeah. But I mean, part of the requirements for this could be something like we can expect that a command might be delayed by as much as 1 second. That's anywhere on the globe. It's going to be like maybe 500 milliseconds. But if you said 1 second delay, it's not going to cause the robot to, it's supposed to be autonomous. It's supposed to handle.
I'm not worried about a second.
Yeah, so that's the worst case scenario is 1 second. So
yeah,
I can't think that fast, so.
Okay. Well, it simplifies my life to do the central server and both people talking to it because that's well-known technology that, we do that every day.
Yep.
And it doesn't have the security concerns of opening up a pipe into your own robot.
No, not at all.
Good night, guys.
Yeah.
Getting late here.
See you, Pat.
Thanks.
Yep.
Night.
I'm going to peel off too. I've got something going on at my work I've got to take care of.
Okay.
All right.
Bye,
Take
Dad.
good next week.
Okay, guys, if everybody's logging off, I'm gonna give Carl a call and stop the recording, okay? Everybody good with that?
Yeah.
Yeah. Sounds good.
Okay. Adios.
Bye, guys.